Welcome. In this video series, we're going to look at finding maxima and minima classify them using different analytical tests. Okay, but just for clarification, we are going to be looking at both absolute maxima and relative maxima. So absolute, also called global maximum, is just really the highest value that a function can attain. And so you can see that if we have a maximum, it is actually a y value. So just make sure to communicate any maxima or minima as a y value occurring at a certain x value. So and all this is that, this is the highest y value that you have. Similarly, in an absolute or global minimum is just going to be the lowest x or y value that you obtain on the entire domain. Okay, now all graphs, if we're on a closed interval, are going to have a absolute extreme value, but we can also have relative or local maximum and minima too. So you might hear me switch between language of relative maximum and local maximum. And all this means is that if we're looking at a small region near X or near C, it's the highest Y value in that region. Okay, the same thing with a minimum. Okay, and for us and for our purposes, local mins and maxes appear as peaks and valleys respectively. So, for instance, something like this would be if we had, like a degree 4 polynomial. This middle piece would be a local maximum, and then these two down here would be local mins because they act as valleys. Okay, and when we look at the grouping of all absolute and local mins and maxes, we call those all extrema. Okay, and if we are talking about a single one, it would be an extremum. Okay, so just some quick things that I want you to try on your own. I want you to sketch a function with two local maxima, one local minimum, and one absolute maximum at x is equal to 2, and no absolute minimum. So just pause the video, try that out, and then once you have tackled that one, try and sketch a function on this particular domain from -2 to 5 such that there's an absolute max but no local max. Okay, so take a shot, pause the video, try it out. And so here's an example of what I have. So for this first one, I have two local maxes. Okay, so I have one there and one there. Again, I'm using language of local. You can use language of relative. One local min, so this is a local min. Okay, and an absolute max. Okay, so your local extrema can be absolute extrema as well. Okay, and then there's no absolute minimum because it's continuing on down. For this next one, you probably racked your brains a little bit and were like, can this even happen? Can you have an absolute max but not a local max? And indeed you can. Because of the definition of a local maximum, right, we say that a local maximum, you have to be on a region near the function. So, and this is actually a point of contention among mathematicians, is whether or not you can have local extreme values at endpoints. And I believe in this course, we're going to take the perspective that no, you can't, because in order for you to have a maximum, right, you need the function defined around the point in which you think is a max, and so that means the function has to exist on both the left and the right. Here in my example, since it does not exist on the left, there's no local maximum, but it is still the highest y value we obtain in this region, so this is an absolute max, but not a local max. Okay, so just the observation of interest is meant for you to recap that you can have local, or you can have absolute extreme values without locals, and actually vice versa too. For example, we saw here that we had a local min, but we had no absolute min. Okay, so just because you have one doesn't necessarily mean you have the other. Okay, but now if we changed our conditions just a little bit, we could think of this in a different way. So here I made this supposition that I had a continuous function. Some of you may have done this in a different way, which is maybe a little bit more clever than what I was originally thinking. But you could say, okay, well, we have the function here, and you have that, and then right, you have this. Okay, but then maybe you do something like this. So this would technically qualify as an absolute max, but then is it a local max? Well, that's where we kind of, according to the definition, does it really work? Yes and no. So this one, you may have thought that this sort of point to discontinuity would have worked. According to the definition, it does work, but it's something where I would kind of look questionably at it. And so if we add the supposition where we have to require the continuous, or if we have to have the function as continuous, what happens to the extrema? Well, that's where we get what we call the extreme value theorem, okay? And then that's what's going to go in this box. So extreme value theorem, okay? And what it says is, if f is continuous on AB, then f attains an absolute maximum and an absolute minimum in this interval. So notice that we have to have a closed interval, okay? Oops, let's not do that. Let's undo that. We have to have a closed interval, and once we have a closed interval, then we can say, yes, there is a maximum and there is a minimum. We don't necessarily have a method to find it, but, well, we are at least ensured that there is one of each, okay? And looking back at our last example, we can say, well, what is the local maximum on our closed interval? Well, that's the maximum, and this would be the maximum, absolute maximum, that is, and the absolute minimum would be here. And actually, this one's really interesting. It would actually be everything else, okay? So there is an absolute maximum and an absolute minimum, but there may not be local maxes and mins.